Right, here's a, a couple questions relating to acids and bases. First one, how many moles of pure sodium hydroxide must be used to prepare 1 liter that is a pH of 12.12? Okay, immediately we have a problem here because this is an acid measurement and this is a base, right? So my first thing is I need to get this measurement into baseland. So I'm going to say that the POH is going to be 14 minus the pH minus the 12.12. So the POH then will be, what is that? 1.88. I think that's right. So the POH is 1.88. So now I need to figure out the concentration of hydroxide ions. And I can do that with this formula. 10 to the minus POH. So 10 to the minus 1.88. Let's do that in decimals here. So 10 to the negative 1.88. Okay, so it's equal to 0.013182567 moles per liter. Now, okay, so moles per liter. Now they want to know how many moles of that you need. So really I should do this. I should say sodium hydroxide is a solid, dissociates the sodium ions and hydroxide ions. And it's a 1-to-1 relationship. So the concentration that I just found out is have hydroxide ions. So that's my 0.01318, etc. So the concentration of the sodium hydroxide would be the same, 0.01318. But this is a concentration, moles per liter, which doesn't make a whole lot of sense because it's a solid, but I guess I could have converted it to moles first. But that's a concentration, and I need a how many moles. So I can use this formula, C equals N over V, to determine the moles. So I'm looking for moles. So I'll rearrange my formula to be equals C equals N equals C times V. So my C is 0.01318, etc. moles per liter times by the volume was 1 liter. So the liters cancel. Was it 1.0? Yeah. So when I multiply that, it'll again be the same thing, 0.01318 moles. But they want 2 sig figs because of this. So it'd be 0.013 moles. Okay. Now, question that you had was on the logarithmic scale. And we saw that the logarithmic scale went from 0 to 14, right? And I didn't really indicate what the differences were between. But a logarithmic scale, and ours is a log base 10 scale, means that if you have 1, if your pH is 1 versus 2, that the difference between these is 10 times. So if I go from 2 down to 1, 1 is 10 times more acidic than 2 is. So if I was at 3, 3 is 10 times more acidic than 2. But if you were to jump from 3 to 1 to say, well, how much more is acidic 1 than 3, you're jumping 2 tens there, so 10 times 10. Each time you move 1 pH unit, it's a factor of 10. So 10 times 10 would be 100. So if you were, say, here at pH of 2 and you're starting at 8, and they wanted to know the difference between those, so there's 7, 6, 5, 4, 3, 2. So it'd be 10, 10, 10, 10, 10, 10. How many tens is that? 1, 2, 3, 4, 5, 6. Yeah. So it'd be 10 to the 6th, 2 would be 10 to the 6th times more acidic than 8. Okay, so each number factor 10.